morning everybody. So today we will see the next part of this chemistry biomolecule chapter, lecture number 2. So see here, it includes the study of, this topic includes the study of glucose, then glucose preparation from sucrose as well as from starch. Then the glucose structure, evidences in regard of that according to the ascent of allocated structure of glucose. So see here, this glucose, glucose already it is known for us that glucose this occurs freely in nature, as well as in combined form, then already you know that glucose is present in the sweet fruits. So such glucose which is present in the sweet fruits, that is the fruit glucose, that is fruit sugar. Then it is also present in the honey as a honey sugar. Then glucose is also found or present in the ripe grapes, approximately 20%. So that is the grape sugar, that referred or term as a grape sugar. So this is the availability of the glucose naturally in different forms. Again, this glucose is a monosaccharide, belongs to carbohydrates, and this monosaccharide possesses or having the 6 carbons. Hence this is the hexose sugar, as well as it possesses or having the aldehyde group. Hence this is the aldohexose. Then this glucose is also known as the D-glucose. You have to use here the capital D and not the small d. So this is the dextrose sugar. So this D, what stands, that is related to the feature projection formula. So we will see this after the completion of this topic. So this is the little bit about the what is glucose. Then we will be seeing how the glucose prepared for our necessities. So see here right now, after knowing this little bit about the glucose, we want to see the methods for glucose preparation. So it is possible for you to obtain the glucose in small scale, as well as small scale production is possible for you, as well as the large scale production is also possible. Production is also possible. So this small scale production, this is the laboratory experiment you have to perform. And prepare the glucose. And this is the commercial method for the production of glucose. Commercial method, or you can say this is the industrial application. So whenever you are interested to produce the glucose in large amount, you have to go by this way, and whenever you want to produce the glucose in small amount, you have to go by this way. So see here, by this way, that is the glucose preparation from sucrose. So already you people know that this sucrose, this is the cane sugar. And the molecular formula of this cane sugar is as like, that is the C12H22 oxygen 11. Then upon hydrolysis it means you have to consider the one water molecule here. Then you have to boil this cane sugar. You perform the boiling of this cane sugar with dilute HCl. So here I am mentioning H plus. So this is the presence of acid. Then boil it. Then you will get the two molecules of monosaccharide C6H12O6 plus C6H12O6. So this is glucose, this is glucose, and this is the fructose. This is the fructose. It means disaccharide is converted into the monosaccharide. Disaccharide is converted into monosaccharide after the boiling with the dilute H2SO4 as well as the HCl, dilute HCl. So this indicates the acid catalyst. This is the acid catalyst, and this acid catalyst is in the form of dilute HCl or dilute H2SO4. Dilute H2SO4. So glucose had been formed. Glucose had been formed. So see here, आप समझ लीजिए कि आप मान लीजिए कि आपको आप जूस प्रोवाइड किया है, लेबोरेटरी में जूस प्रोवाइड किया है, केन जूस तो केन जूस जो है उसमें केन शुगर रहता है, वो सक्रोज है, दैट इज द डाइसैकराइड. So that you have to consider according to the protocol. Then आप मान लीजिए कि बीकर में आपने जूस लिया, केन जूस लिया, और उसमें बाद में डाइल्यूट H2SO4 और डाइल्यूट HCl ऐड करना है. ये ऐड करने के बाद आपको स्प्रिंग पे ऊपर उसको बॉईल करने का है. बॉइलिंग यू हैव टू कैरी आउट द यू हैव टू परफॉर्म द बॉइलिंग. जब आप बॉईल करेंगे तो रिएक्शन हो जाएंगे क्योंकि डाइल्यूट H2SO4 में वाटर है, वाटर. सो दैट इज द हाइड्रोलिसिस ऑफ द सक्रोज. सक्रोज इज प्रेजेंट इन द केन जूस व्हाट यू हैव कंसीडर्ड फॉर द एक्सपेरिमेंट. So this hydrolysis occurs or takes place. As a result, the monosaccharide, two type of the monosaccharide had been formed. तो आप कैसे पता करेंगे कि ये जो दो मोनोसैकेराइड है, दो है, वो अलग है? तो आपको कोई प्रोसीड्यूर करना पड़ेगा नेक्स्ट. तो आप क्या करेंगे, इसमें बाद में ये बॉइलिंग के बाद यू अलाउ दिस टू कूल डाउन, उसको कूल होने देने का बाद में आपने यू हैव टू ऐड द अल्कोहल. सो इन अल्कोहल सॉल्यूशन व्हाट हैपेंस, this fructose can get dissolved in the alcohol, and glucose does not dissolve in the alcohol. बाद में आप क्या करेंगे कि you have to run the filtration technique से क्या होगा, ये जो अल्कोहल सॉल्यूशन है उसमें फ्रुक्टोज जाएगा और ऊपर जो है वो बीकर में आप तो एक्सपेरिमेंट करेंगे लेबोरेटरी में, तो वो फनेल जो है उसमें ये solid particles that are the residues, it means the glucose crystals, that are the glucose crystals. So by doing this little bit about the glucose preparation, the next, that is the commercial method of glucose preparation or the industrial method of glucose preparation. So by this method, how to prepare the glucose? See here, by this industrial method. So by industrial method, you do one thing. Here, you have to consider the raw material in industry. As like you make available the tubers. These are the potatoes. So this is the agro-based, because here you are interested to produce the glucose on large scale. That is for specific purpose. You want to produce the glucose on large scale. So this is the industrial method. So in this case, you have to consider the big tanks or the vessels in the industry, and then you have to run the protocol. You have to apply the protocol according to the scientific research. So here, by this industrial method, this is the agro-based material you make available in the industry. So this material means this is the polysaccharide in the form of starch. So the molecular form of starch is C6, then H10O5 at N times. So this is the starch, or this is the cellulose, which is the agro-based material which is made available in the industry, and then the N number of H2 again you have to perform the hydrolysis here. Then in this case, this is the acid catalyst, again acid catalyst. You have to maintain here, whenever you want to produce the glucose on large scale, it means आप बड़ी मात्रा में बनाना चाहते हैं क्या ग्लूकोज, तो इंडस्ट्री में बना रहे हैं, तो ऐसा रॉ मटेरियल आपको अवेलेबल करना पड़ेगा, बड़े बड़े वेसल या टैंक रहेंगे, उसमें आपको हाइड्रोलिसिस करना है, तो अकॉर्डिंगली वो सब अरेंजमेंट रहती है इंडस्ट्री में। तब आप क्या करेंगे कि इसको बाद में यू हैव टू मेंटेन सम कंडीशंस फॉर दिस hydrolysis of starch, for this large amount hydrolysis starch, for this hydrolysis of this large amount of the starch, you have to maintain the conditions as like the here dilute H2SO4, then along this, that is the temperature 393 Kelvin, then 2 to 3 bar pressure. So when starch hydrolysis is performed with the help of dilute H2SO4, with the help of dilute H2SO4, 393 Kelvin temperature and 2 to 3 pressure, under pressure, then we will get the n number of glucose molecules, C6H12O6. So this is the glucose. So this experiment what tells for us? This is polysaccharide is converted into the monosaccharide. So all these monosaccharides means these are the monomers. So the general reaction of this is like this. See here. Suppose M stands for monomer. Then many monomers come together in n number, and then the complex polysaccharide have been formed. So this is the start. This is the raw material. Then you have to perform the hydrolysis. You have to consider the n number of H2O. So in presence of this dilute H2SO4 as well as 393 Kelvin temperature and 2 to 3 bar pressure, the n number of you can say the n number of here monosaccharide units had been obtained. N number of monosaccharide units had been obtained. So this is the general reaction of the glucose preparation in industry, and this is the molecular reaction in regard of the glucose preparation in the industry. तो आप लोग देखिए, ये आप बड़ी मात्रा में ग्लूकोज बनाना चाहते हैं तो ये मेथड से जाना पड़ेगा आपको, ये मेथड से। तो ये ग्लूकोज बनाने के बाद कुछ प्रॉब्लम्स रहते हैं, क्यों कि आपने यहाँ ये जो एसिड कैटलिस्ट यूज किया है, एसिड कैटलिस्ट डाइल्यूट H2SO4, ये तो ये हार्मफुल है, ये ग्लूकोज में रह जाएगा, इसलिए आपको इसको हटाना, यू हैव टू रिमूव इट। तो अब क्या करेंगे कि इसका जो इफेक्ट है इसको न्यूट्रलाइज करना है, तो जो वेसल है, जो बड़ा टैंक है जिसमें ये सब मोनोसैकेराइड आपको मिल गए हैं, जो ग्लूकोज यूनिट n नंबर ऑफ यूनिट ग्लूकोज के मिल रहे हैं, तो आपको इसमें ऐड करना पड़ेगा। क्या करेंगे आप पहले इसके साथ यू हैव टू ऐड द chalk powder, then what happens as a result, here the calcium sulfate pipette had been formed. So this pipette, you have to remove this pipette, then again here in this glucose impurities are there, and because of these impurities here there is a coloration. So your interest is that you have to remove this color. So for the decoloration, again this material you have to add in this material the activated charcoal. So this can act as here as adsorbent. So it can absorb the color entities. Then what happens? The discoloration occurs or takes place. Then you allow this material, you allow the cooling. So after cooling, in this case you have to arrange the filtration. Filtration technique. After this filtration, you obtain the filtrate on one side, and then the residues, it means here again you will have been get the glucose crystals. So by this way it is possible for you to produce the glucose. So this is the glucose preparation on large scale in the industries. So see here, in this topic the next part is evidences, proofs in regard of the glucose structure or glucose mineralization. So it is known for us that glucose possesses or having this already it is known for us that glucose is the probably most abundant organic compound on this earth. Glucose is probably most abundant compound on this earth, and it acts as monomers in large number of the carbohydrates such as in starch as well as the cellulose and so on. And because of that we need to do the in detail study of the glucose. So see here, the assigned glucose structure is like this. This is the what we can say, this is the allocated glucose structure. It means the glucose had a 6 carbon chain, carbon as like this, 1 2 3 4 5 6, and here this is the 6 carbon chain. Then the glucose possesses are having the 4 chiral centers as well as at one terminus it possesses are having the aldehyde group. Then at the other terminus it exhibit the presence of the first degree alcohol. So these are the structural aspects, predicted structural aspects. So we want to check out that is it true or not, and for that purpose we have to use the different type of the chemical reagent in the laboratory. And like this is the hydrogen iodide, then the hydroxylamine, then hydrogen cyanide, then bromine water, then acidic anhydride as well as the nitric acid. So these are the different chemical reagents we have to use for them to prove that the glucose had a such structure or not. Is it glucose possesses or having the aldehyde group at one terminus, then the primary alcoholic group at another terminus, then the 4 chiral centers of the carbon, then the carbons are arranged in a straight chain. So glucose having the open straight chain 6 carbon structure, and for that purpose this is the assigned structure of glucose, this is the allocated structure of the glucose. So these are the evidences when you perform the reaction of glucose with this type of the chemical agents or the chemical reagents, then you got the confirmation about that the glucose had have such predicted structure. So accordingly we'll be see the one by one reaction. So the first reaction about the glucose is that the number 1, that is the molecular formula of glucose. So see here, you have to apply here, it is possible for us to apply the mole concept here, and then the mass percent, accordingly you arrange the mass percent, and then the conversion. As a result you will have to get the CO2 plus H2O from the glucose, and so this is the what we can say, this is the elemental analysis and interpretation. Then this is elemental analysis and molecular weight determination. So accordingly the its molecular formula found to be C6H12O6. So the empirical formula is like CH2O. So here in the ratio of 1 is to 1, 1 is to 2 is to 1, 1 is to 2 is to 1. So this is one experiment. This is the experiment which tells for us that glucose had the 6 carbon, then the 12 hydrogen and the 6 oxygen atoms. So this is the confirmation on the basis of elemental analysis and the molecular weight determination that glucose had this type of molecular formula. Then by doing this, the next experiment, that is the second confirmation, or the second, you can say the second evidence, proof in regard of the glucose structure. That is the second evidence, second proof. Presence of straight 6 carbon chain in glucose. So for this purpose you have to use the strong reducing agents. I like AHI. So here this is glucose here, and whenever you perform the reaction with AHI, you can mention this on the arrow. This is the strong reducing agents. So prolonged heating, you have to arrange the prolonged heating of this strong reducing agent with the glucose. Then you will have to get the N-hexane. N-hexane means NCS3. This is the linear arrangement of glucose molecule. So see here, तो आप लोगों को मालूम है ये जो HI है, this symbol indicate the prolonged heating of the glucose with this strong reducing agent HI. So what it does, this strong reducing agent hydrogen iodide always react. इसकी ये टेंडेंसी रहती है, क्या टेंडेंसी रहती है? It always react with the carbonyl group as well as the alcoholic group, and then it bear or produces. When it react with the carbonyl of the alcoholic group, then it bear or produces the alkane. So here this we can conclude that the glucose must have the carbonyl group as well as the alcoholic groups, and that's why only the alkane, this N-hexane had been formed. So this is the another proof of the evidence. This confirms that glucose had the carbonyl group as well as the alcoholic groups. After the reaction with the strong reducing agent HI. So this is the second confirmation about the glucose predicted structure or glucose assigned structure. Then the third prediction is like this. See here, that is the third prediction. Presence of carbonyl group in glucose. कि आपका इंटरेस्ट है, क्या इंटरेस्ट है कि ग्लूकोज जो है, ये जो ग्लूकोज है हेक्सोस शुगर, इसमें कार्बोनिल ग्रुप है, ये आप लोग जानना चाहते हैं। तो आप क्या करो कि जो रिएक्टेंट है वैसा एक दूसरा जो रिएक्टेंट है उसका इस्तेमाल कर सकते हैं। सी हियर, दिस इज द structure of the glucose. Again this assigned structure of glucose. Then you have to arrange the reaction of this glucose or provided material with NH2OH as well as with the HCl. Then what you will have been get? This reaction resulted into the formation of oxide. So CH double bond NOH, then CHOH at 4 times and CH2OH again as it is. Here this HCl react with this glucose and it resulted into the formation of CHCl and CHCl and OH on one side. Then the rest of things are same. That is at the bottom CH2OH. So see here. अब चेक कर रहे हैं आपको जो मटेरियल दिया है, जो ग्लूकोज है उसका रिएक्शन बना रहे हैं इसके साथ. दिस इज हाइड्रोक्सिलामाइन. So this hydroxylamine perform a special reaction. That is the elimination reaction. And this elimination, it perform the elimination reaction always only with the carbonyl group. So this is the identity of this chemical agent. So when the elimination reaction takes place, then at that time what happen here? See here, these two hydrogen atoms means this reaction here takes place and like this. This reaction here takes place and like this. This is the nitrogen and these are the two hydrogen atoms and OH on one side. Then here this is the carbonyl group of the glucose. You can mention this as like C double bond O. Then the elimination reaction takes place here. Here the water molecules eliminated. And then this CH bonded with nitrogen and OH remains as it is. So this type of reaction resulted. So this is the glucooxide. And this confirm or indicate that the glucose had the carbonyl group. Because this reactor, this eliminating agent, this dehydrating base only react with the carbonyl group. So this is the evidence or proof. This confirm that the glucose had a carbonyl group. Then HCl. Already you people know that this HCl, this is the nucleophile. So this nucleophile, it means here this hydrogen cyanide. This also perform the special reaction. इसकी टेंडेंसी है कि ये जो हाइड्रोजन साइनाइड है ये भी एक स्पेशल रिएक्शन दिखाता है, एडिशन रिएक्शन. And this addition reaction is performed only with the carbonyl group. So here what happens? This is the nucleophile. Here negative charge is there. Here positive charge is there. So what happens? This negative part of this reagent, the negative part of this nucleophile, that attack on the carbon here. Because this is the carbon and these are the oxygen. This is the hydrogen, CHO. So this is more electronegative. So here the partial negative charge, here partial positive charge. So this negative part, nucleophile attack on the carbon. As a result, what happens here? The addition reaction occurs or takes place. CH on one side, this Cl minus is there, and on another side OH is there. Because this H plus goes towards the negative part. Like this. So this is the addition reaction. This is also the reaction of this hydrogen cyanide with the glucose is resulted into the formation of cyanohydride. It means that the glucose possesses or having the carbonyl group. So these are this perform the elimination reaction and this perform the addition reaction, and this is the clear cut proof for us, or this is the evidence that the glucose had a carbonyl group. glucose had a carbonyl group. Then next to this, the next evidence in regard of the predicted glucose structure, in regard of the assigned of the allocated glucose structure is that see here. You have right now we have to consider the another reagent, chemical agent for this conformation. So see here, that is the fourth reaction. That is presence of carbonyl group as an aldehyde group. So you can arrange this reaction with the help of bromine water, which can act as a mild oxidizing agent, and this mild oxidizing agent is always responsible for conversion of the aldehyde group into the acidic group. So this bromine water, mild oxidizing agent, had a tendency whenever it react with any compound in the laboratory, then this mild oxidizing agent is responsible for the conversion of aldehyde group into the acidic group, So here, see here, this is the CHO, then the rest of things of the glucose are same, CH2OH. You have to perform the reaction of this along with the bromine water, Br2 bromine water. This is the mild oxidizing agent, and then you will have to get the COOH, CH2OH at 4 times, and then CH2OH at the bottom. So what type of change had been noticed here? This aldehyde group, the carbonyl group must have been the aldehyde group, because this reagent never react with the ketone group. It does not oxidize for the ketone. So this is again, this confirm or this indicate that the carbonyl group which is present in the glucose, that must be the aldehyde group. So this is the proof from this mild oxidizing agent for us in regard of the structural aspect of the glucose. Glucose had a aldehyde group at one terminus. Glucose had a carbonyl group, and that is the aldehyde group at one terminus. So this is the next proof. This is the next confirmation. So we can check out this with the help of. This is the next confirmation reaction. In regard of the glucose structure. That glucose had the five hydroxyl groups in it. So see here, this is the chemical agent or the reagent. In presence of pyridine, you have to use in the laboratory. So this is acetic anhydride. This acetic anhydride CH3CO at twice O. So the structure of acetic anhydride is like this. This is the acetic anhydride. At the middle, oxygen is there on either side. So this type of arrangement is there. So what happens? This reagent or this chemical agent have a tendency that it react only with the alcoholic groups, and does not react with the carbonyl group. Hence it is used here when the reaction of the anhydride performed with the glucose, considered glucose, then in presence of the pyridine, the stable penta-acetate had been resulted. Along with the acetic acid. So see here what happens. acetyl groups from this acetic anhydride, acetyl groups from this, they can occupy the positions of the active hydrogens because the glucose possesses of having the alcoholic groups here at the center of the chiral carbons, 4 OH groups are there, as well as 1 OH group is at the bottom here. So see here what happens, the active carbons had been replaced by the acetyl groups of the corresponding acetic anhydride. Acetyl groups of the corresponding acetic anhydride. These active hydrogens had been replaced. So whenever the active hydrogens means what? The hydrogen atoms, those are connected or attached to the more electronegative atom. Here oxygen is the more electronegative. So these are the active hydrogens. These active hydrogens have been replaced by the acetyl groups from the acetic anhydride, and then that resulted into the ester formation. So this is the penta ester. Here, and this is known as this exists as a stable penta acetate. So this is confirmation. This confirms that the glucose had 5 hydroxyl groups in it. OH groups in it. Then here again what happens, the some part of the anhydride when attached or goes along with the active hydrogen, then acid formation takes place, acidic acid. So here this question mark indicates the acetic acid also had been formed when the reaction between the considered chemical material, it is the glucose, and the acetic anhydride takes place in presence of the pyridine, then the ester and acid formation occurs or takes place. So this is again the one nice proof or the nice evidence in regard of the presence of the glucose had 5 hydroxyl groups in it. Then after that, the last evidence, see here, the last evidence is that about the glucose structure, and that is this, the presence of primary alcohol group. So see here, you have to use in the laboratory, you have to use the this strong oxidizing agent. Like nitric acid. Nitric acid is a strong oxidizing agent, and it has a potential, or it has a ability. This chemical agent had an ability to oxidize for the aldehyde group, as well as for the primary alcohol only. It means the nitric acid does not oxidize for the secondary alcohol groups, and oxidizes only for the carbonyl group in the form of aldehyde, as well as the alcoholic group in the form of first degree alcohol, and that's why you have to use the nitric acid and perform the reaction in the glucose. See here, suppose this is the glucose, so you have to take it as usual, CH2H, and then you have to perform the reaction between glucose and this nitric acid. So the oxidation occurs or takes place here, then you will have to get the COOH, then CHOH, the secondary alcohol at the middle, then at the bottom you will have to get the carboxyl group again, group here, COOH. Then on this side also it is possible for you to arrange the HNO3. So this is the nitric acid. Here also oxidation takes place or oxidation. So the one product, that is gluconic acid, that had been resulted when you perform the reaction between the mild oxidizing agent bromine water with the glucose. So you obtain the gluconic acid. So consider here the gluconic acid, that is COOH, CHOH at 4 times, and then the CH2OH. So this is the glucose, and this is the gluconic acid. And this one is the saccharic acid. This is the saccharic acid. So this saccharic acid bases are having the two carboxylic groups. Two carboxylic groups. So these are the acidic groups here. So see here, this nitric acid. Whenever you perform the reaction between the glucose and nitric acid, then you will have to get the saccharic acid. You will have to get the saccharic acid. It means it indicates that it tells for us that nitric acid had a potential to react with the carbonyl groups as a aldehyde group as well as with the primary alcohol only, because the change which is noted here in the product that is at the bottom place where the primary alcohol is present as well as the top where the carbonyl group aldehyde is present. It means it possesses ability to to oxidize for both the aldehyde to form the acid as well as the primary alcohol to form the acid. Hence the saccharic acid had been formed. Then when you perform a reaction of the nitric acid with the gluconic acid, this is the product that had been obtained by you by the reaction between the mild oxidizing agent bromine water with glucose. So this is gluconic acid. When gluconic acid and nitric acid react to each other, then you will have to get this saccharic acid again. What it tells for us? It tells for us that this chemical agent or this strong oxidizing agent oxidizes the primary alcohol here. Hence this change has been happened here and this change is not noted here. So this is the confirmation. This is the last confirmation about the glucose structure. So all these are the evidences, and how you have to remember for this all the evidences. So I am going to tell you the little bit information. You try to recall the word halo. Halo for the halogens I and then the Br. So here you arrange the HI strong reducing agent and then the another that is bromine water. So these are the two chemical reactants. These are the two reactants you have to use for the confirmation of glucose structure. Then after halo word, you do one thing. You know that the plant needed the essential nutrients, and one of them is the nitrogen. So this nitrogen here, nitrogen associated compound is hydroxylamine NH2OH perform the elimination reaction. Then another one is the hydrogen cyanide. Hydrogen here, nitrogen is there. Hydrogen, this is the perform the special reaction, addition reaction. Then the another one, this is the strong oxidizing agent, strong nitric acid, HNO3. Here also nitrogen is there. So these are the nitrogen associated chemical agents. So you remember from this nitrogen, from these chemical reagents, and from halo word, these two chemical reagents. So these 5 chemical reagents you have to use to perform the confirmation reactions about the glucose predicted structure or assigned structure. And the one which is odd one, that is the acidic acid, AC2O, or you can here say that this is the CS3COI twice and oxygen. So this is acidic anhydride. If you people feel this video or discussion nice, could you please like and subscribe it? That proved a lot for me. Thank you.